Algebra 1 lesson on 6.1 slope intercept form. I said that we're having a lesson on 6.1. Okay, 6.1. Essential question. How can you represent a linear function in a way that reveals its slope and intercept? Okay, before we start, let's do some exploration group work. Okay, so the Andrew wants to buy a smartphone that costs $500. His parents will pay for the phone, and Andrew will pay $50 each month until the entire amount is repaid. Okay, and the loan repayment represents the linear situation in which the amount y that Andrew owes his parents is dependent on the number of X payments he has made. Okay, Andrew wants to buy a phone that costs $500, right? And then his parents will pay for the phone, so it means that they bought it, right? But now what that means is that Andrew owes the parents the $500, right? And he's gonna make certain payments, $50 each month. Got it. Okay. So A is asking you to write a linear equation that describes such a situation. Well, first of all, it depends on what? It depends on the number of payments, right? So that'll be the X number of payments. And Y represents the dollars. So graph has that already, so I'm not too worried about it. So we could say let X equal to number of monthly payments. Yeah. So one of the easiest way to do this, right, is look at the intercept values, right? How much does he owe his parents from the very get-go? That's $500. And you're taking away how much each month? 50, right? 50 times the number of month. So we would normally write that in math classes as y is equal to negative 50x plus 500. Oops. Let me rewrite that. Negative 50x plus 500, right? But, I think this makes a little more intuitive sense in that we started with 500 and we're taking away 50 each, right? So the y-intercept in this case is what? 500, right? And then the slope is whatever is right in the front, right? Front of the x is negative 50. But let's just think about that. Let's just not copy paste. Okay. Find us, what is a slope? Slope is change in y and change in x, isn't it? But what is change in y? Change in y is the change in amount owed, isn't it? And x is each month. So that's the change in amount owed per month. Because he's paying back for $50 a month, that is a change. But because you're paying it back, the amount that you owe decreases, hence the negative, right? So it's actually, better to sort of think about negative 50 over 1. Of course, we write as negative 50 because anything divided by 1 is itself, right? Okay, there you go. Let me put the answers on the left-hand side, okay? All right. Use the y-intercept and the slope to graph. Well, first of all, let me just maybe write maybe a little bigger. There you go. I like that one better. So let me make some copies of that. Oops, no. No, I don't want the image. There you go. And maybe make some more. Okay, that's good. All right. So we had 500 to begin with, right? It is $50 every month, so that month one over there goes down by 50. Goes down by another 50. Oh, it looks like I'm going along these points right here, right? And then because I kind of see that happening, I'm just going to draw a line. And I could sort of visually see that it has to go through this point right there. So I think that's kind of good. I'm almost there. Oh, wow. It's snapping into places. I didn't realize that. Okay, there you go. It's not quite as good as I wanted it. Let me try one more time. So this, oopsie. And I know that this point goes all the way down here. All right, let me see if I could do this. If the notability will work with me. It is snapping into places. All right. There you go. I think that's a little better. So that is it. And I don't think you need to necessarily draw an arrow in this case because we're not really interested in time that goes past 9 months. Well, we don't want this part because it goes into negative money territory. And then we don't care about this part because it's what happened before you bought the phone. So that really doesn't pertain to the question at all, right? Yeah, so just leave it out there. Okay, so I did that. Check. I do have some additional questions though. Can you tell me what this each one means? Like E, I just have to ask some questions here. What does y-intercept mean in the context of the question? F, what does the slope mean in the context of the question? And G, when will Andrew pay off his debt? Right? What does that mean? Just think about it for a second. Okay. I have actually completed this for you ahead of time. I mean, those three questions. And here it is. Okay. Y-intercept means the $500 is the money that Andrew owes initially, right? Owes his parents initially because his parents pay for the $500. Slope is negative 50 over 1, means the Andrew will pay back $50 each month. Pay back means what he owes goes down, right? And the G, when will Andrew pay off his debt? Well, that means y is equal to 0, isn't it? So you set the y equal to 0 here. And then you solve for it. It's 10. It'll take 10 months to pay off the $500. Okay. It's not bad, is it? All right, guys. Let's move on to the next question, okay? Next page. Here we go. And we're looking at, finally, we're looking at the slope-intercept form of the equation. If a line has an m slope and an intercept 0b, then the line described by the equation equal to y equals mx plus b. I'm going to make a bit of a, I'm going to, sorry about this. I actually don't know how to shut this off. Hold on. Let me play something. There you go. I should shut that up. Okay. This is one of those occasions when textbook has extended the definition, and I actually have talked it over with. Sorry about this. Wow. There you go. Okay, so I've spoken to very, very, very capable people, and they agree with me on this one. Okay. The y-intercept, by definition, okay, let's always go back to the definition. The definition of the y-intercept is what? Y-intercept is the value of y coordinate, right? Where line intersects y-axis. Now look at this. If you think about it, y-intercept is the value of the y-intercept, y coordinate, is the value of y coordinate, a value, right? So what that means is that this is a coordinate of the y-intercept. It should be y-intercept b. That's it. Not 0b, but simply b. Okie dokie. All right, guys. Now let's focus on the example question right here. Write the equation of each line in slope-intercept form and then graph. Well, there are a couple of ways to do this actually. Okay, let's look. Slope is 3 and the point is in 2, 5. So if it's 2, 5, okay, 2 is over here and the 5 is 1, 2, 3, 4, 5. 5 is right there. Oopsie. I don't want to put that over there. 2 and a 5. Because slope is 3, it's 3 over 1. So when I see that, I think of it as positive 3 over positive 1 or negative 3 over negative 1. Well, that helps me to draw a better picture. So you go up 3, 1, 2, 3 across 1. Up 3, across 1. Or you go down 3, left 1, down 3, 1, 2, 3, left 1, and so on and so forth. And when you draw a line, 1 second, guys. There you go. And then it looks something like this. Okay. And here we do draw an arrow to indicate that the line goes on forever, right? And then by doing this, we notice that the y-intercept here, b is negative 3, and the slope was given to us, right? Which is a 3. No, did I say negative 1? Wow, negative 1 and row 3, right? That was interesting. I must have been thinking about the slope. Slope is equal to 3. So we know that therefore y is equal to 3x minus 1. But that method, while it worked this time, may not work all the time. So we need to find a more robust way, right? So what we got to do is sort of like, okay. So we know that we have y is equal to mx plus b. We need to do it in a way that it works in more situations. In other words, a more robust approach, right? So in this particular case, we were given, let's take a look at this. We were given the x value and the y value and the m. Hold on a second. I have this, and this. Sorry, my bad. X, y, and m. Let's just plug it in, shall we? And if you do that, that is 5 is equal to m is 3, x is 2, plus b, and the b turns out to be negative 1. Therefore, y is equal to, slope is 3, x minus 1, which is a b. Okie dokie. Alright, guys. Okay, let's look at the next one, shall we? In this particular case, the line passes through 0, 5. Oh, that is the y-intercept, isn't it? So that implies that the b is equal to 5, and the x and the y is over here, right? So I suppose I could draw this first. Okay, so that is 1, 2, 3, 4, 5 right there. 2 and 10 is 2 is over here, and 1, 2, 3, 4, 5. Another point. But looks like the slope is what? Negative 502. No, sorry, 502, right? But let's not just, yeah, let's just do that, because I could clearly see that this is 2 and this is 5. If you continue on the other side, it's going to be here, isn't it? 1, 2, 3, 4, 5. 1, 2 goes here. All right, guys. So it's going to look something like this. There you go. And the graph looks something like that. Okie doke. All right, but let's not forget what we're here to do. But I think graphing sometimes helps. So we know that y is equal to mx plus b. And I just figured out that I have the b, which is 5. The y is equal to 10. And x is 2. right? When you solve for that, what do we get? Well, we get 5 is equal to twice the m, and m has to be 5 over 2. That matches my finding where I found out over here my slope was 5 over 2, wasn't it? Yeah, that was it. So we say, therefore, y is the slope, 5 over 2, x plus the y-intercept, which was given to us in a coordinate form, and that is 5. Sounds good? Okay. Let's look at example 2. In this particular case, write each equation in slope-intercept form, then graph the line. Ooh. Okay. So, I don't understand this direction because it says write the equation. I see. It says write it in the slope-intercept form, which means that you have to write this in y equals mx plus b, right? I was wondering if that was the case, why would they give it to me here? But here's the thing, though. The second question is in a different form. That's called a standard form, remember? Right, so we do have to convert it first. But if it's already in a slope-intercept form, we don't have to do anything. It's already in that form, right? So, yeah. So what's my slope? Is 5 over 1 or negative 5 over negative 1, right? And my y-intercept is negative 4. Okay. Oops, let me just pull that out because maybe I might make some mistakes, okay? Give a little space between the writings. So that's negative 4. Let's start with that first. 1, 2, 3, 4. Going up is 5. 1, 2, 3, 4, 5. Right 1. 1, 2, 3, 4, 5. Right 1. How about let's do the other one, negative 5. 1, 2, 3, 4, 5, negative 1. Okay, that's not bad. So we will connect these two lines. Okay, there you go. And I'm going to move it a little bit. Okay. All right, guys. This is my way of doing it simply because I don't have a ruler, right? But ruler might be a little easier. So the reason why you want to go as far, you want to get the points as far apart as possible to give yourself the best and the most accurate line, okay? Yeah, when you have like trying to draw a line between 2 points that are very close, you lose in accuracy. So, okay, we good, guys? All right. In this one, we do have to convert to the slope-intercept form. Remember, this right here is in a standard form. In order to solve for the slope-intercept form, which is in y equals mx plus b, we do have to solve for y. The first thing we're going to do is we're going to subtract 2x from both sides, yeah? And when you do that, what we end up with is 6y is equal to negative 2x plus 6. And now what we're going to do, we're going to divide everything by 6. But we know that the negative 2 over 6 is negative 1/3, right? Yeah, so I would just write as negative 1/3 right there. Okay, and whatever work that you have, it's hard for me to emulate it here, but I generally tend to write that very lightly, right? So it might be like this, using a pencil, so it doesn't distract. So yeah, okay. So now that we solve for y, my slope is what? Negative 1 over 3 or 1 over negative 3, right? Because we're going to be able to go both ways, but you don't have to write that. You should just think it, okay? And then y-intercept, b is equal to 1, because y-intercept, so it's right here. So now let's go up 3, up 1, left 3, 1, 2, 3. Go up 1, left 3, 1, 2, 3, up 1, left 3. All right, let's go the other way. Let's go down 1, 3, down 1, 1, 2, 3, down 1, and there you go. Okay, so now I'm going to connect these 2 points, the furthest one apart, the best I can, and then center it a little bit, and there you go. That's a beautiful looking line. All right, guys. So that is how we would draw the line. Okie dokie. All right, so we do have, hold on, what's going on? I got blank one. I have this one that's done. Why did I have 2 blank ones to begin with? Sorry about that, guys. Okay, so here we go. Determine the solution of the equation in 2 variables. Okay, not example 1, 2. What we would do is look at the action verb. It says identify the slope. First thing I'm going to do, and here I'm going to do slope and intercept. We're going to identify the slope and intercept of the graph that's given to us. And the keyword is and. We're on number 2, interpret what they mean, and then write the equation in a slope. Okay, number 3. And then we're going to write them in a slope intercept form and use it to solve the problem. Yeah? So there's at least 3 things we're doing. First of all, we're going to identify the slope and the y-intercept. And then we're going to interpret what they mean and write it into the slope intercept form. And there you should be thinking. You don't have to write this out. But let me put in a thought bubble. You should be thinking y is equal to mx plus b. Okay? So you could change the order a little bit. So as soon as I find the slope and intercept, I will just put it immediately into the y equals mx plus b form, and then I'll probably interpret it. Okay? All right, let's look at the example A. It says, for one taxi company, the cost y in dollars of a taxi ride is a linear function of the distance x in miles traveled. The initial charge is $2.50, and the charge per mile is 35 cents. So basically it's 35 cents per mile. And then on top of that, it has an additional question. Find the answer to that. Okay, let's do the initial part first. Initial charge, the word initial always goes with B. Initial value, right? Initial value of the y. Here y is the dependent variable. So initial value of the y, which in this case is $1, $2.50. And then anytime you have some sort of ratio, a rate, right? Charging, how much is the charge per mile, right? Whenever you have a rate, that's always the slope. So that is the slope right there, m. So my m is 35 cents, right? And we have y-intercept is $2.50, right? We don't need the dollar signs over here, okay? So I don't think we really need to interpret this, because in this particular case, it actually told us, but we will, right? So we know that the y, although we don't write it, it's actually y of x, the y that depends on x, okay? So you don't have to write of x, but if you want to, it's okay. Mx plus b is 0.35x plus b, which is 250. Let's interpret this, right? So, you know what? I think it might be actually best to go with the direction in which they told us this way. 1, 2, 3. Let's interpret this right here, right? Yeah, so because they told us this is represents the initial charge, right? So this is a rate per mile. Okay. Now, that should be it, right? And then if I have to explain what that means is the cost of taxi, right, for the ride of X miles. So if I had to interpret that, right, so this is like cost of riding taxi X miles. Okie dokie. So I think that really answers all the questions over here, right? Now we have to answer this question. Find the cost of riding 10 miles. So therefore, that'll be y of 10, isn't it? So that'll be 0.35 times 10 plus 250 times 0.235 gives you 3.5, okay? Plus 2.5, that gives you 6. There you go. So let's interpret what this is saying. Yeah, okay. But we do want to double check. Therefore, taxi ride of 10 miles cost $6. Okie dokie. Let's do another example here, shall we? A chairlift descends from the mountaintop to pick up skiers at the bottom. Okay. The height in feet of the chairlift is a linear function of the time in minutes and begins to descend as shown in the graph. Find the height of the chairlift after 2 minutes. Okay. This one is more of looking at the graph, isn't it? Okay. All right. First of all, what's my y-intercept? My y-intercept is 5,400 feet, which represents the keyword here is what? Initial height of the chairlift. And what is the x-intercept in this case, right? Because in addition to the example here, what this is asking, I have to do the example 2 here. Oh, this is the slope. Never mind. For a second, I thought I had to find the x-intercept. All right. So what is my slope? Let's do that, shall we? The slope is change in y and change in x, which is y2 minus y1 over x2 minus x1. Let's consider this to be the second, and that's a set of first numbers. That's 2,400 minus 5,400 divided by 4 minus 0. You could change the order. It's going to come out the same thing, right? And that turns out to be negative 3,000 over 4. And I believe half of that is 1.5. Half of that is, yeah, it's negative 750. Basically, negative 750 over 1. I'm just thinking it, right? So basically, for every 1 minute, it descends 750 seconds. So it's 750 feet. So what that means is that chairlift descends 750 feet every minute. Or we could say per minute. Okay? So now, given that information, I have the y-intercept b. That right there is a b, and that right there is m, right? So we're going to write y of x is mx plus b. M is negative 750 x plus the initial height of 5,400. Okie dokie. All right. So the question is, what is it after 2 minutes? Okay. So y of 2, negative 7,500, 750 times 2, that's 1,500, right? Yeah. Plus 5,400. When you do that, what do you end up with? We end up with 3,900. So what that means is that after 2 minutes, therefore, after 2 minutes, the the chairlift is at 3,900 feet, or 3,900 feet from the ground, right? All right, guys, that is about it. And here is your turn. If you need to copy the numbers down, there you go. And the bottom numbers are here. Okay. Let me pause the video. So why don't you pause the video and try this? All right, guys, here are the answers. And there you go. Okay, guys, I shall see you in the next video. And if you have any questions about any of these, be sure to make the best use of the tutorials that we have. And okay, I'll see you in class. Bye-bye.